Why do computers count from zero? Computers traditionally tally numerical values starting from zero. For example, arrays in C-based programming languages start from index 0. What historical reasons exist for this, and what practical advantages does counting from zero have over counting from 1? Note, this question asks for well-explained technical answers, not merely opinions, and is intended to cover computers in general rather than just programming. This question expands upon the programmer's question: why are structs/arrays zero-based?
Counting arrays from zero simplifies the computation of the memory address of each element. If an array is stored at a given position in memory, it's called the address. The position of each element can be computed as. If you consider the first element the first, the computation becomes not a huge difference, but it adds an unnecessary subtraction for each access. Edit. The usage of the array index as an offset is not a requirement but just an habit. The offset of the first element could be hidden by the system and taken into consideration when allocating and referencing element. Dijkstra published a paper Why Numbering Should Start at Zero, PDF, where he explains why starting with 0 is a better choice. Starting at 0 allows a better representation of ranges.
While the principles below apply to decimal as well any other base, counting from zero in computers can be easily understood naturally from the fixed-digit binary system of representing numbers used in computers. If you have 8 bits, then there are 256 possible combinations of ones and zeros that can be expressed. You could use these 8-bit to express the numbers 1 to 256, but this would leave out 0, which is useful in mathematics as a number in and of itself, so they are used to express the numbers 0 to 255. This already sets a precedent of a natural order starting from 0, all zeros in a binary representation, to 255, all ones in an 8-bit number. Considering the system of representing numbers, starting from 0 makes sense because 0 is the first number in the system, so 1 is the second number, and so forth. An additional reason why starting from 0 in computers is so convenient is due to the concept of offsets. An offset is a number representing the distance from a location in memory or hard disk or any other addressable medium. In computers, practically all data is stored linearly, meaning that there is an order to the data, first a byte, a second byte, etc. It is convenient to express location of areas of data by an offset. What is the first byte in a block of data? It is at offset 0, which means it is found 0 bytes after the first byte in the block of data. While it is possible to have one designate the first byte, this creates complications in the representation of the data for several reasons. By the exclusion of 0 from being used to address data, you reduce the number of things you can address with an 8-bit number by 1. To calculate the offset, which is necessary at the hardware level of data access, at some point you have to subtract 1 from the numbering, which introduces a complexity. Pointers to a block of data always point to the first block, so arithmetic is straightforward when you start from 0. The first byte in the first block of the first cluster of data is 0 plus 0 plus 0 when you start from 0. It is 1 plus 1 plus 1 to 1 minus 1 when you start from 1. The arithmetic for this when you start from 1 with nested data structures like this example can be confusing.
Never thought an opportunity for an armchair philosopher such as myself would come along on Superuser. There is a fundamental misconception at heart here, because non-philosophers tend to skip over the minute details. In short, computers do not count from 0, but denomination of position starts from 0. There is nothing confusing about this perceived inconsistency between computer and human, counting techniques. Let's decompose the question. Why do computers count from 0? They do not count from 0. computers tally values starting from 0. For example, arrays in C, E. The index, indicator of position, tally, starts from 0. The count of elements in an array where there is a single element at index 0 is 1. 0 is practical to represent a void of something or the middle point of a scale. It is not practical for counting anything because it is impossible by definition of 0. In the same sense as the middle point of a scale, the 0 can be used to represent the very edge, absolute beginning, of a collection. The question is meaningless because it is inconsistent between tally values and count from 0. So yes, computers do tally from 0, but they count from 1. The two words bear different meaning. Tal middle.ly, tal e. Noun? An account or reckoning, a record of debit and credit, of the score of a game, or the like. Anything on which a score or account is kept. A number or group of items recorded. Count, count. Verb, used with object. To check over, the separate units or groups of a collection, one by one to determine the total number, add up, enumerate, he counted his tickets and found he had 10. To reckon up, calculate, compute. To list or name the numerals up to, close your eyes and count 10. Dictionary.com. The practical reasons are adequately described by Dubsch. I have nothing to add there. If only we could have a CS professor, from the 60s, to give a historical account.
I think this has been covered before by Professor Dr. Edgar W.
Dijkstra, Burroughs Research Fellow in a letter dated the 11th of August 1982, CFU'd 831.
Titled, Why Numbering Should Start at 0.
Are there reasons to prefer one convention to the other? Yes, there are. Note also that Dijkstra was on the ALGOL 68 design team late until 1968. ALGOL 68 permits arrays either from 0, 1 or any number the programmer deems appropriate for the algorithm. Cf. The making of ALGOL 68 recounts. Can you define triangular arrays? Someone, Tony Hoare?
Interrupted.
Not just triangular, but even elliptical, replied Ard, and showed how. Specifically, in ALGOL 68, when arrays, and AMP, matrices, are sliced they get an index at 1, so there is a bias towards 1 arrays. But the first lower bound can be moved to start at the 0th position by specifying at 0, for example vector x4:99 at 2, matrix y4:99 at 1, 4:99 at 0. Similarly, there is a default slash bias of from 1 in do-odd loops, unless from 0 is explicitly stated, and from 1 for the integer case I and tilde, Isaac and $C tilde, $choice clauses. It seems that Dijkstra's comments about the March 1968 draft report Mr. 93, and his insistences provoked what is arguably a pre-Usenet flame war. There are writings which are lovable although ungrammatical, and there are other writings which are extremely grammatical, but are disgusting.
This is something that I cannot explain to superficial persons. U230.
The ALGOL 68 final report FR came out on the 20th of December 1968 when it was presented at Munich meeting and then adopted by the working group. Subsequently the report approved by the General Assembly of UNESCO's IFIP for publication. Around December 23, 1968 Dijkstra, Duncan, Garwick, Hoare, Randall, Siegmuller, Tursky, Woodger and Garwick signed the AB 31.1.1.1 Minority Report, page 7, published 1970.
If you want to support the channel, please consider subscribing.